Okay, everyone, in this video, I'm going to show some examples on how to make predictions on whether the entropy of the system will be increasing or decreasing. And so that's really thinking about the sign of delta S of the system. Less. Okay, so our first example is boiling water. So boiling water is going from H2O liquid going to H2O gas. Now, we know that the inherent entropy of a gas is higher than that of a liquid because the atoms are further apart and therefore they can occupy more spaces, they can have more arrangements. And so I would say that the entropy of the products minus the entropy of the reactants should be greater than 0 or a positive number. Another way of saying this is that the delta S of the system should increase. It should be greater than 0. Okay, so in this example, we have iodine gas going to iodine solid. And so the entropy of the product should be less than the entropy of the reactant because we're going from the product as a solid and the reactant as a gas. And so therefore, whenever we do S products, got that, guys? Minus S reactants, that we would expect this to be less than 0. Or we can say that the delta S of the system should be less than 0 or negative. Okay, and then our last example is calcium carbonate decomposing into calcium oxide plus CO2 gas. If we look at this, we have a couple of ways of thinking about it. One is thinking about the complexity of the atoms, and you can say that there's more complexity on the product side than there is on the reactant side because you have more molecules, more atoms. I guess not more atoms, more molecules. You can also look at this in that in our products, we have a gas. And so we would expect that the entropy of the products, the total entropy of the products, should be greater than the entropy of the reactants. And therefore, we would expect that the delta S of the system should be greater than 0 or increasing. Okay. I hope this helped with kind of beginning to make applications and very qualitatively think about the sign of the entropy for a reaction or a system. In the next few videos, we're going to start putting numbers to this so that we can make sure that we understand how these calculations work.